Alright, welcome. Let's work Calculus AB number 2 from 2023. So Stephen's swimming back and forth along a straight path, so this is going to be a straight line motion problem. Stephen's velocity is modeled by v of t, where t is measured in seconds and v is measured in meters per second. Alright, so we're going to be finding all times t at which Stephen changes direction, and we're going to give a reason for our answer, but I think this would be easiest if we brought in a calculator. Okay, now this problem's got some trig in it, so we need to make sure we're in radian mode. Okay, but I'm going to go into y equals, and I'm going to plug in 2.38 times e to the power of negative 0.02t, negative 0.02, times the sine of pi t divided by 56. Okay, so we got it entered there. And so we want to know times between 0 and 90 where the direction changes. So it's going to be with the sine of v changing, and I'm going to change the window to go 0 to 90. And, t jump 10 each time. But then we're going to graph, and we're going to see, okay, it's got a positive velocity, and then turned around and went negative for a while. Okay, so that's just going to be one time, so evidently it's just one lap around the pool. So we're going to calculate a 0, that is to the left of the 0. Something like, we're at 45, so like 75 should be to the right of that. Yes, give it a guess, and then we've got t equals 56. Okay, so I'm going to say for A, t equals 56 is where the sign of velocity changes. Okay. And you can't totally see it, but that's just what I wrote there. Nothing more than that required. Okay, find the acceleration at time t equals 60 seconds. Okay, so I'm going to say acceleration at 60 is what I would get if I took the derivative of velocity and plugged in 60. And we can have the calculator do that for us. We're going to go back out to the main menu, and we're going to call for a derivative, math 8, and we're going to take the derivative of, derivative with respect to x of y1 at the point where x is 60. And we get negative 0.036. That's part B. That's all we have to show. Oh wait, no, and include units measured. No, that is not all I have to do for part B. All right, so let's scroll up a little bit and indicate units of measure. Okay, well, the units of velocity would be meters per second. Units of t was seconds, so that would be meters per second per second. And then is Stephen speeding up or slowing down at time t equals 60 seconds? Well, we need to know about velocity. So velocity at time 60 is equal to, well, we'll just use the calculator for that as well. So now let's call for y1, and we're going to plug in 60 into the velocity formula, and we'll get negative 0.160. And I'm going to say since v of 60 is less than 0, and a of 60 is less than 0, same sign, speeding up, right? Because the velocity is negative and decreasing. So the absolute value of velocity is getting bigger. I'd say speed is increasing. Or they ask speeding up, so I'm going to say speeding up. And that was part B. Part C, find the distance between Stephen's position at time 20 seconds and his position at time 80 seconds. Show the setup for my calculations. All right, so, okay, yeah, they didn't give you an initial condition. I was wondering kind of like where the trickiness was here. Probably shrink this down. Get it out of the way. Okay, so now distance, but really it's the difference between position at 20 and position at 80. So what I'm going to do is I'm going to say, all right, x of 80 minus x of 20, well, that's going to equal the integral of velocity. Okay, we don't need an initial condition. So we're going to say that's just equal to the integral from 20 to 80, no, not 20 to 280, 20 to 80, of v of t dt. That's the change in position. So I'm going to just run that integral on the calculator. So ask for math 9 from 20 up to 80 on y1 dx. And we got 23.384. And that will be the distance between Stephen's position at 20 and position at 80. All right. And then that was part C. Whoops. And then part D is total distance, and we can find that by integrating speed. Okay, so on the interval 0 to 90, it's going to be the absolute value of v of t dt. And this is another thing we can use the calculator for. So this is very calculator heavy. I'm not sure what happened to my integral. I guess I'll just write it again. 0 to 90 of the absolute value of v of t. Okay, I'm going to go over here to the calculator. And we're going to ask for another integral from 0 up to 90 of the absolute value. And we get absolute value in math. I thought, maybe it's over here in number, yeah. Absolute value of y1 with respect to, no, that'll give us something very different. Okay, we want to get all the way over there with respect to x and let it think for a second. And it's thinking for a long time on this one. Suspiciously long time. All right, there we go. 62.164 meters. 62.164. Okay. And that's number 2 for AB for this year. Thanks for watching.